This is Integrated Math 1 from McGraw-Hill's Reveal Math Integrated 1 course. In problem number 1, we are doing a multiple choice question. Select the graph that shows that the solution set to 7 is less than or equal to n plus 5. So I'm just going to go ahead and recopy that problem down. 7 is less than or equal to n plus 5. We need to isolate our variable. Right now we have a plus 5. We need to undo plus side both sides. The way that we undo both sides is we subtract 5, and when we do that, these are gone, and my left side is now going to be 2 is less than or equal to n. Typically, I tell my students you can either read this one backwards and change the way that you pronounce this inequality. You can say n is greater than or equal to 2. I know that this is a less than or equal to symbol, which is why typically I rewrite this with the variable on the left, the number on the right. Whenever you switch the sides of these, you need to switch this sign as well. This is going to be a greater than or equal to, and this rule here just makes sense really quickly, because if I have the saying that 1 is less than or equal to 2 and I switch the sides to 2 and 1, the only way for this inequality to make sense is if it also switches and says that 2 is greater than or equal to 1. All right, so there is our expression, and we're going to say that n is greater than or equal to 2. So that means I'm greater than 2 going to the right of 2. Right away, that means A and B are possibilities, not C and D. And then because I have an equal to, it is going to be a close point. The correct answer here is A. And as a hint to everyone, whenever you have a greater than or equal to, it's kind of like this is the head of the arrow, and the arrow is pointing to the right. So you should have an arrow pointing to the right. All right, in number 2. Open response. Eduardo is writing a historical novel. He wrote 16 pages today, bringing his total number of pages written to more than 50. How many pages P did Eduardo write before today? Complete the inequality that represents the situation, then solve the inequality. All right, so I already know that I'm going to be filling in some things here. Luckily, I have some whiteout, so I can get rid of that question mark, get rid of that question mark, and get rid of that question mark as well. All right. So from here, I know that if he is more than 50. So the keywords that I'm looking at is more than 50. Right here, I see more than, guess what number goes right there? 50. More than 50. So the pages that he wrote 16 pages today. So it's 16 more pages. So pages plus 16 makes more sense to write in this scenario. And then if I solve this, I'm going to write this off to the side. This is 16 plus P is greater than 50. I'm going to subtract 16 on both sides. Subtract 16, subtract 16. I'm going to do that. Those 16s are gone. P is now greater than, this is going to be a 34. So I'm going to say P is greater than a 34. Moving on to number 3. A farmer said that for every row of seeds he plants, he can harvest 6.5 bushels of tomatoes. The farmer needs to harvest at least 52 bushels of tomatoes. What is the least number of rows that the farmer will need to plant? So in this type of problem, the key words that I'm looking at is the at least. So needs to harvest at least 52 bushels. So that's what I want to key in here. So it's either one of these two, right? It's either greater than or equal to 52 or greater than 52. And we have to decide. That's a terrible 5. Greater than 52. So if it's at least 52, it can be 52 or more than, right? So it can be equal to in this case. So it doesn't say strictly more than, so it doesn't make sense to use this one. I'm going to go ahead and erase that one. So we know this is part of our inequality, and my 5s are just not very good tonight. Let me go ahead and rewrite. This is 52. And he can harvest, every row of seeds, he can harvest 6.5 bushels of tomatoes. So what is the least number of rows that the farmer will need to plant? Okay, so this looks like we are going to be multiplying bushels by rows. So I'm going to say bushels is going to be 6.5 bushels per row, so times row. Whenever you see the word per, did I see the word per, or did I make that up myself? I guess the word every can also mean multiply. So it's going to be 6.5 bushels for every row. So times R for row. I'm just making up a variable here. And that needs to be at least. So it's going to be greater than or equal to 52. So there's the greater than or equal to 52 piece. And once I solve for this, then I'm going to figure out what is the least number that he can plant. So we're choosing the smallest possible integer, aka whole number for R. So all I need to do in this one, this is a decimal, that's a multiplication. I need to undo this multiplication. Right now, R is being multiplied by 6.5. The opposite of multiply by 6.5 is to divide by 6.5. Divide both sides by 6.5, and that's going to give us our answer. So, is there a way to do this without a calculator? Yes, I think the easiest way is to probably multiply the top and bottom here by 2, by the way, those 6.5s are gone, right? So my new inequality is going to be r is greater than or equal to, okay, if I multiply these two by 2, it's going to be 104. The denominator here, 6.5 times 2. The whole point of multiplying by 2 is to get rid of this 0.5. I know that 6 times 2 is 12, 0.5 times 2 is 1, 12 plus 1 is 13, so this can be over 13. And that is not a nice number. Does 13 go into 104? I'm not seeing a nice way. Do we need to really use long division? I was really hoping to avoid that. Let me go ahead and, yeah, I think I'm just going to use long division. I was really hoping to not. Okay, so 13 goes into 104. I guess we're going to guess. I don't know. My first intuition is 8, but that might be too big. Let's see. 13 times 8. 3 times 8 is 4. Carry the 2. 8 times 1 is 8 plus 2 is 10. 100. Oh, it's literally just 8. Okay, that was embarrassing. We're going to come over here and say, well, 104 over 3, or 13 is the same thing as r. Pen though. R is greater than or equal to 8. So there's our inequality boiled down. We started with our inequality, went to this, and now the question is, what is the least number of rows? Well, the least number, we have to be bigger than or equal to 8. 9 would be a cool number, but we can get even smaller. We can go 8. We can't go to 7. 7 is not greater than or equal to 8, but 8 is indeed greater than or equal to 8. So the correct answer here is 8 rows. 8 rows. All right, number 4, find the solution set to this inequality. All right, so usually the way that I start these is to first move the variable. I have a 3D here, a 4D here. If I move the 4D over here, I'm going to be subtracting a 4D. And if I do that, I'll have a negative D variable. I don't like having negative D variables or negative variables in general. So instead, I'm going to move this 3D over on this side. So the way that I do that, I subtract 3D, I subtract 3D, and those 3Ds are gone, leaving behind just a -8. I still have that less than or equal to symbol. If I have 4D minus 3D, those are my like terms. They both have variables. So 4D minus 3D is just 1D. I don't write 1D, I just write D. 1D is unsimplified, so I'm just going to write D, and that's still plus 2. Okay, so if I have a D on this right side, that means that all of the other things, the non-variables, have to go to the other side. So I'm going to next subtract 2, whoa, that was a terrible 2, subtract 2. And that means that what's left behind, those are gone. I have a D right here, and that's going to be this less than symbol. And then if I have -8 minus 2, they're both the same sign. I'm going to add them and take the sign larger. That's going to be -10. So there is a good answer, and I'll take it, right? So if you're doing a solution set, to be technically correct, you have to do the set of all numbers D, where D... or you can say, you can go like this, you can say where -10 is less than D. That solution set is okay. Typically, we put the variable on the left though, so this will pass, but I will say usually we put the D over here and the -10 over here. Again, because we switch the sides like we did in problem number, what was it, problem number 1 or something, we need to also switch the sign. This is going to switch from a less than to a greater than. Still, we're going to say all of this solution set stuff, and this is saying the solution set of D such that D is greater than -10. Cool. And then we move on to the next page, to number 5. So which inequality has solutions represented by this graph? Ooh, okay, so do we have to solve every single one of these to figure out which one it is? I think we do. It's kind of a lot of work. Luckily, they all seem pretty easy. Let me do A over here first. So if I have 5 minus x is greater than 4, I'm going to subtract 5 to get the variables by themselves. I have a -x now is greater than, why did I, -5, -4, what am I doing? I have to do the same thing to both sides of the inequality. So this is a -5, which is correct. That has to be a -5. Silly Mr. Sindel. And 4 minus 5 is a -1. And I need an x by itself. Right now I have a -x by itself. I can either multiply or divide by a negative. I choose to multiply by a negative on both sides. When I multiply both sides by a negative, notice that I'll have a negative and negative cancel out, leaving behind just an x. Notice whenever you multiply or divide by a negative, this inequality symbol is going to switch from a greater than to a less than symbol. And then I have a -1 times a -1, which is a +1. That is not this graph. I want this graph to essentially say x is greater than 4. because it's not equal to. There's an open point here, and it is going to the right. You can kind of see the arrow is pointing to the right. Okay, what about b? Let's try. For b, I have the equation, or the inequality, 2x plus 1 is greater than or equal to 9. From there, let's go ahead and subtract 1, I get 2x is greater than or equal to 8. And then if I divide both sides by 2, x is greater than or equal to 4, which is really, really close. X is greater than or equal to 4. That's x is greater than 4, so b is also out of the running. I guess we could have eliminated it right from the get-go because it had an equal to sign on the very bottom. Therefore, this one is an open point. It has to be between c and d. And let's go ahead and analyze c right now as well. For c, I have 2x minus 5 is greater than 3. Let's go ahead and add 5 to both sides of the inequality. That's going to leave us with 2x is greater than 8. And then I'm going to divide both sides by 2, divide by 2. This says x is greater than 4. And that's what we're after, right? X is greater than 4. The correct answer here is C. Just to show you that D is not the correct answer, in case you thought that was the correct answer, here's how you would have done D. 6x minus 7 is greater than 5. From here, I would add 7, and I get 6x is greater than 12. Then I would divide by 6, and I get x is greater than 2, which is not the thing that we're looking for. All right. Number 6, consider the inequality 5 plus 2 times the number n is less than or equal to 11. Okay, that's just a literal equation. Write down what it tells you. So it tells us 5 plus 2. So I'm going to write down 5, in pen though, 5 plus 2. I should probably write this a little bit higher up here so I have some room. It told us 5 plus 2 times a number. So if you're ever wondering, like, is it this thing times a number n? Well, no, they didn't say parentheses. So you just say times a number. You literally just say times the number n. And the number n, you literally write down the number n. That's a number n. I guess it's a variable. And you say is. Is usually means an equal to sign, but if it says is less than, then you say it's a less than symbol. So it's a less than symbol. And then it says or equal to. So now I'm going to put the equal to underneath. And then 11. Just write out every single word by word. And now you have to do order of operations, right? So what happens first? Do you do add first or do you multiplication first when you're trying to simplify? When you're trying to simplify, just as a reminder, you're using PEMDAS. Please excuse my dear Aunt Sally, where when we go this direction, that's how we do, let me turn my iPad, simplify. We simplify before we solve. And then once it's simplified, then we go this other direction and we solve, or AKA we undo things that are being done to the variable. So this happens first. Multiplication happens before the addition. This happens before this. So this is really going to say 5 plus 2n is less than or equal to 11. And then from there, I can start undoing things. Everything over here is nice and simple. Simple on the left, simple on the right. Let's go ahead and solve and undo the addition first. So I can undo, I guess I can undo this plus 5. I know it's reading backwards, but you can say minus 5 on both sides of the inequality, leaving behind a 2n is less than or equal to 6. And then from here, I'm going to divide by 2, and it's going to be less than or equal to 3. And one thing that I'm noticing about the instructions, it says select all other representations, which means it might be A, B, C, and D. You can select all 4 if you want. So the first thing that jumps out at me is n is less than or equal to 3 is literally A, but it could be other things as well. Because notice, sometimes they put the variable on the right. If we put the variable on the right, what would that look like? If the variable's on the right, that means the number is on the left, and we've switched these sides. When we switch the sides, we switch this sign, and this is going to turn from a less than or equal to a greater than or equal to. Is this thing visible as well? Well, this thing looks like D. I think the correct answer here is A and D. All right, what about number 7? We need to solve this thing. And we need to write the solution using set builder notation. I'm a little bit confused on what that means. Maybe I should go back and read the textbook a little bit better. Let me rewrite this problem really quick. This is going to be 8 times the quantity of t plus 2. Notice that I try to write my t's with a little curve on the bottom so you don't mistake them for pluses. If you are ever worried about your notation, make sure that I can distinguish between your t's and your pluses, please. And then plus 7 times t plus 2 minus 3 times t minus 2. And that's going to be less than 0. So in this case, we have a bunch of distribution. We're going to distribute the 8 into the t and to the 2. So 8 times t is 8t. 8 times 2 is 16. And what symbol goes in between? You just copy that symbol down. So there's going to be a plus in between. All right, and now I'm going to distribute. And notice how I'm going to write my distribution over here. Technically, I took all of that 8 and distributed. I'm going to take all of the sign in front of it. This positive 7 is going to be distributed to this t and to this 2. 7 times t is a 7t. What sign goes in between here? Well, this is it was a plus, so that plus has to be preserved. We say it's still a positive 7t. And then I'm going to distribute the positive 7 into the 2 as well. 7 times 2 is a 14. And again, what sign do you do? Well, a positive times a positive is a positive, so this is still a plus 14. And this is where it gets tricky. Most students make the mistake of not distributing the negative with the 3 here. The negative 3 gets distributed to the t and the negative 2, and this is going to be a negative 3t or minus 3t, and then negative 3 times 2 is a positive 6. This is the key thing, positive 6. I would say the majority of students will miss that step right there, and that's going to be less than 0. Okay, now remember, with PEMDAS, we have to simplify first, and then we will solve. This is not simplified on the left-hand side of our inequality, which means all of the like terms need to be added up. I have variables, variables, and variables, and I'm looking at the sign in front as well, so maybe I should underline a little bit further to make sure I'm including the sign as well. If I have 8t plus 7t, so far that's 15. I'm keeping the running total in my head. 15 minus 3 is 12. So this is going to be 12t. Okay, what about the other terms? I have a constant, a constant, and a constant. Notice how I'm circling part of that sign in front of those constants as well to make sure I have the right signs. Let's do 16 and 14 add up to 30. 30 plus 6 is 36. So I'm going to say a positive 36. And then I'm going to copy down the rest of our inequality, less than 0. And then from here, we just need to solve for t. So I'm going to get 36 on the other side, minus 36, minus 36. And I'm going to say 12t is less than negative 36. And then from here, I'm going to divide both sides by 12, divide both sides by 12, and t is less than negative 3. And it says write the solution using set builder notation. Not quite sure what that means, but set notation, I guess. So set notation is the set of all answers where t is the answer such that t is less than negative 3 is technically how you write the set notation. But I mean, in my class, I'm okay just writing like that. Perfect. Okay, let's move on to number 8. Hopefully I have enough room here. In number 8, it's saying we just have to solve this thing. Okay, it's nice and straightforward. There's a bunch of ways you could solve this. I know that the classical way of solving this is to add 3 to both sides. I guess I can start that way. I don't need to rewrite this. There's plenty of room here. So plus 3 on both sides of the inequality. That leaves a negative 4/5 x is less than or equal to 20. And now it's time to get rid of the 5 and get rid of the negative 4. And you'll notice it used to have a negative up front. I put the negative up top. It doesn't matter where you put the negative. So I'll write this down in the notes just in case you forgot. Negative out front of 4/5 is the same thing as negative 4 on the top of 5, which is the same thing as positive 4 over a negative 5. All of those are the same thing. Just choose one negative. It is not equal to. Don't accidentally say it's negative 4 over negative 5. You can only have one negative. From here, I need to, this is saying multiply x by negative 4 and divide x by 5. I can undo both of those at the same time. Here's the shortcut. Are you ready? You're going to multiply both sides by 5. My 5s are really terrible tonight. Multiply both sides by 5. And at the same time, divide both sides by a negative 4. Divide both sides by the negative 4, which is the same thing as saying multiply by the reciprocal of the coefficient. The coefficient being the number out front, reciprocal just being a fancy way of saying flip this fraction. So when we do that, watch what happens on the left-hand side. 5 and 5 cross-cancel. Negative 4 and negative 4 cross-cancel, leaving behind just the x like we want it. And, I have to be careful here. I just made a mistake because I just divided by a negative. Whenever you're divided by a negative, I flip the sign. This is going to be greater than or equal to. And now I have to figure out what's going on over here. So I think the easiest way to tackle this problem is to first look at 20 divided by negative 4, and then after that, we'll multiply by 5. 20 divided by negative 4 is a negative 5. So the way that you write that is you say that one goes and turns into a 1. This one goes and turns into a negative 5. Just a reminder, 20 divided by negative 4 is a negative 5. And then negative 5 times that positive 5 is a negative 25. So I'm looking for this answer that says greater than or equal to a negative 25, greater than or equal to a negative 25. The correct answer should be A. Moving on to number 9. All right, the Science Club is planning a car wash fundraiser. Halona, I guess, writes and graphs an inequality and to represent the number of cars C in the Science Club needs to wash to make a profit. Okay, I see. It needs to be, if I were saying this, I would say C, the variable, has to be greater than or equal to, because it's a closed point, so there is an equal to, and 200. So that's what I'm after. Which inequality could she or he have solved for the situation? Select all that apply, which means we have to solve all 4 of these and figure out which of them could give us this, because the answer could be A, B, C, and D. We could select all 4 of them. So we have literally 4 problems to do. Let's try them. So A is going to be 2 times the quantity of C plus 1 n quantity minus 50 is greater than or equal to 352. So from here, I'm going to distribute the 2. This is going to be 2C plus 2 minus 50 is greater than or equal to 352. From here, I'm going to simplify before I solve. I'm noticing that I have some like terms in these constants. This 2C is still there, still 2C, but 2 minus 50 is a negative 48. And then I have a greater than or equal to 352. Now that everything has been simplified on the left and everything has been simplified on the right, let's go ahead and solve. So the way that I'm going to solve is I'm going to move, I'm noticing that this side has variables, therefore this side should be for the constants. Let's move the constant to the constant side. Let's go ahead and add 48 to both sides. Add 48 to both sides. That leaves behind, those are gone, it's going to leave behind a 2C and greater than or equal to, and what is that number going to be? 400, it looks like. And then from here, I'm going to divide both sides by 2, divide both sides by 2, and C, therefore, is going to be greater than or equal to 200. And notice that is what we're after. So that is at least one of the solutions, if not multiple. I need to write a little bit smaller to have enough room for all 4 of these. So luckily, I have technology. I'm just going to use my shrink ray on this thing. So let's go ahead and grab you. Let's go ahead and resize and shrink you down. Shrinky dink it down. Okay, there you go. Let's try B a little bit smaller this time. There's going to be 310 plus C is less than or equal to 3 times the quantity of C minus 30. From here, I'm seeing that I need to do some distribution. 3 times C is 3C. 3 times a negative 30 is a negative 90. Copy down the rest of this inequality. 310 plus C is less than or equal to that thing. And then from here, I like moving the variables first. I choose to move the variables to the left side in this case. I know that it'll make a negative C, but I prefer my C's to be on the left side anyway, because I know I want my C's over there. It's whatever floats your boat or sinks your sub at that point. I'm going to put minus 3C, minus 3C. Those are gone, leaving behind a negative 2C over here on the left-hand side with a 310, and I have a negative 90 on the right-hand side. Now, since I've dedicated the left-hand side for my variables, my right-hand side must be dedicated to my constants, aka my numbers. Let's go ahead and subtract 310, subtract 310, and that's going to move that, and I have a negative 2C is less than or equal to a negative 400. And then from here, I'm going to divide both sides by negative 2, so we'll say divide by negative 2, divide by negative 2. C is, okay, we divided by a negative. This sign flips to a greater than or equal to, and a negative divided by a negative is a positive. 400 divided by 2 is 200. And yet again, I have a C greater than or equal to a 200, which is the thing that we were looking for. So the answer is A, B, and it might be more than that. We have to check C and D as well. All right, let's try C. Hopefully I have enough room up here. Let's go ahead and zoom in. Maybe that'll make my handwriting a little bit smaller. So C is 20 times the quantity of C minus 1, n quantity, is greater than or equal to 4,000 with 3 zeros. Wow, okay, let's try it. So distribute the 20. 20 times C is 20C. 20 times a negative 1 is negative 20. Rewrite the rest of the inequality, greater than or equal to 4,000. From here, I noticed that the right-hand side has a variable on the right side, or the left-hand side has a variable, the right-hand side does not, which means left side is for variables, right side is for constants. Let's move the 20 over to the right side by adding 20 to both sides. Add 20, and I get 20C is greater than or equal to 4,002. Oh, 4,020, I can add. I accidentally wrote down a 2 there. I meant to write down 20. 4,020. And then now I'm going to divide both sides by 20, and I'm laughing because there's no way this is going to work out. There's no way. So C is greater than or equal to, well, let me do 2 problems. I'm going to do 4,000 divided by 20, and I'm going to do 20 divided by 20, and the answer is going to be whatever this is, right? So for this first question, 4,000 divided by 20, I can say cross off a 0, cross off a 0, same thing as dividing the numerator and denominator by 10. And then 400 divided by 2 is the same thing as half of 400, which is 200. And 20 over 20 is 1, so 200 plus 1. The answer is going to be 201. 1. Close, but no cigar. That ended with a 1 right there. So not C. And let's check D as well. So in D, what do we have? Do I need to use a shrink ray on C? Is there enough room? Let's try. We need 5 times the quantity of C plus 1, N quantity, minus 200, fit it in here, here we go, plus, or is greater than or equal to 250. Okay, I gotta move it over a little bit to the left. Here, let's go like right there. Is that enough room? Is greater than or equal to 250. All right, what's gonna happen here? Distribute. 5 times C is a 5C. 5 times 1 is a 5. Minus the 200, just rewrite everything else out, is greater than or equal to 250. From here, let's go ahead and combine my like terms on the left-hand side. I'm noticing that I have a positive 5 and a negative 200, which means I have a 5C minus 195 is greater than or equal to 250. From here, we're going to move the constants to the right side by adding 195 to both sides, adding 195 to both sides. Therefore, 5C is greater than or equal to, what is this going to be? It's more than 300. It's 445, I think. And then from here, we're going to divide by 5, and C is going to be greater than or equal to, well, that number is really close to 450. 450 over 5 is much easier for me to solve because that's the same thing as 45 over 5, and then I'll add the 0. 45 over 5 is 9. Add the 0 is 90. This is really, really close to 90. It's a little bit less. Therefore, it's 89. So 89. And I have no idea how that is even close to what that is. Not even close. So the correct answer is A and B. Whew, big problem because there are lots of problems within it. All right, number 10. Michaela wants to plant a square garden and enclose it with a fence. She has 120 feet of fencing available, and she wants the sides of her garden to be at least 6 feet long. I mean, that seems like it jumps out to me as a thing that I need to write down. At least 6 feet long means greater than or equal to 6, right? Because if it's at least 6 feet is fine, and 6.1 feet is fine, and 6.2 feet is fine. So it could be equal to 6 or a little bit bigger than 6 is what at least means. Complete the inequality to represent the possible side lengths. Okay, well, I know, it's asking for the range of values. So we need to set up an inequality and then solve it for this one. This one will be fun. Okay, so let me reread the problem to see if I can get some more clues. She has 120 feet of fencing. I mean, somehow I'm going to be using 120. And she wants the sides of her garden to be at least 6 feet long. Okay, I understand. So what we have is all 4 of these added up are going to have to go up to 120, right? So I'm going to say 4 of these sides has to be equal to 120. No, that's not necessarily true because each side could be a different length. Oh, it's a square garden. So if it's a square garden, they all have to be the same length. I can multiply 4 times s, and I can say that is equal to 120. Can I not? Where does this inequality come in? That's my question. Here, let me work through this. If I could totally be wrong, guys. Let's go with it, right? Let's go ahead and divide by 4, and I can say the side lengths are equal to 30. That doesn't make sense because the side lengths need to be between these two amounts. And it even tells me that the perimeter is equal to 4s. There's my 4s that I came up with on my own. I didn't even see that clue down there. Oh, she doesn't need to use all the 120. Like, I see. So it could be, she could decide to make each of these sides 1 feet. Who knows? Like, she doesn't have to use all of these 120 feet. It could be 1, 1, 1, and 1, and she just has, she's only used 4 of those feet. Oh no, but it says at least 6 feet long. I see. So, that's what we want to say. I finally understand the concept of this problem. So let's go backwards here. What we need to say here is, let me think. The best I can come up with here is that there are 2 inequalities because I'm kind of seeing 2 different problems. The first problem is we need to use less than 120 feet in total, and the second problem is each side has to be at least 6 feet long. So let's just make 2 inequalities, and we'll combine them at the very end right here. I think that's the best way forward. So I want to say that The sides need to be at least 6 feet long. So sides need to be greater than or equal to 6. There's the first inequality. Pretty straightforward. And what about the second inequality? I know that if I multiply s by 4, 4 times s, aka the entire perimeter, this thing cannot exceed 120 feet because I don't have that much fencing. So it needs to be less than or equal to 120 feet. And then I can solve that one all over again. Divide by 4, and s is less than or equal to 30. So those are the bounds. I have to say I'm bigger than 6 and I'm less than 30. The way that we write that down is we say our lower bound is here and our upper bound is right there. Let me go ahead and use some whiteout so I can be fancy-pantsy in my notes. I can say, erase these guys and say we have to be at least, change my color, bigger than 6, and we have to be less than 30 for each side, which makes sense because like at least 6 feet long per each side. So that's what we said just in that inequality. And then on this inequality right here, that can't be bigger than 30 because otherwise we go over 120 feet barrier. That seems good to me. Let's try another one. Okay, number 11. Solve this inequality and this inequality and combine them using the word or. All right, so let's try that. So we have 4 plus g is greater than or equal to 3. And then I'm going to do an or right here. 6g is greater than or equal to negative 30. Pretty straightforward to solve these guys, right? You just subtract 4, g is greater than or equal to negative 1. Then I still have the word or, and then divide by 6, g is greater than or equal to negative 5. So just graphing these really quickly, I can say this mini graph is a point, why am I writing 0? A point at negative 1, and I'm going to the right of negative 1, so it's going to be a point, a closed point to the right of this. G is greater than or equal to negative 5 is a point here at negative 5. It's a closed point and it's greater than or equal to negative 5. So again, this is going to the right. And I'm combining these with the word or. So let's put these both on the same graph. I have some room, so let's just, move these guys up. And then I'm going to say, okay, if they're both on the same number line, I have a point here at negative 5, which is more to the left, and I have a point here at negative 1, which is more to the right. Both of these are closed points, and they're both going to the right, which means this point goes like that, right? If I combine these with the word or, remember it's inclusive or as opposed to exclusive or, which means if I choose, okay, let me ask the question. Is the number right here, let's just do a test point. Is this test point negative 4, which is slightly more to the right or greater than negative 5? Is negative 4 greater than or equal to negative 1? No. Or greater than or equal to negative 5? Yes. It is. So this is in the solution set. If that's in the solution set, that's in the solution set, that's in the solution set. Everything here is in the solution set. And I combine these just by saying, okay, well, as long as you're bigger than that negative 5, you work. So you can say the final answer here is that G needs to be greater than or equal to the negative 5. And you could make a simple graph if you want. You could say, oh, it wants set builder notation. Okay, so here's the set builder notation. You put a line here, a G here, and we say it's the set of G such that G is greater than or equal to that negative 5. Excellent. And then moving on to another problem, right? Ooh, almost done. How many? Oh, we're getting close. There's 18 problems here. Number 12. Which graph shows the solution set of this one and that one? So we're combining these words. So let's rewrite this. 3n minus 1 is less than 5, and negative 2n plus 3 is less than 11. So from here, we're just going to add 1, reverse PEMDAS, right? So 3n is less than 6. Then we're going to divide by 3, n is less than 2. Okay, we're going to combine that with the word and. What's going on over here? I need to subtract 3. Negative 2n is less than 8. From here, we're going to divide by negative 2. If I divide by negative, the sign flips. So it was a less than, now it's a greater than. I have an n is greater than a negative 4. So just a mini graph to get us started. If I have a point here at 2, it's going to be an open point because it's not equal to. None of these are equal to, which means you sir, are not correct. B, you're not correct. So negative 2, and again, it's less than positive 2. Over here, we have a point at negative 4, and it's greater than negative 4, open point, of course. And I'm combining this with the word and. So putting these both on a single number line, negative 4 is more to the left, 2 is more to the right, open point at both of these. Remember, 4 goes to the right, so 4 goes to the right, 2 goes to the left, 2 goes to the left. Whenever you have an and, it's wherever there's overlap, right? So there's overlap only in between the sections. So we're looking for a section that's in between -4 and 2. A section in between -4 and 2 looks like A. Number 13, we're going to solve this thing. Easy peasy. Here we go. Absolute value of h plus 3 and absolute value is less than 5. For absolute values, they turn into two different problems. The first problem, you just drop the absolute value symbol. You say h plus 3 is less than 5. And the other one, you're going to multiply everything outside the absolute value symbol. You're going to say h plus 3. Everything on the outside got multiplied by -1, which means this sign flips and this sign flips. It's essentially like saying greater than -5. That's not exactly how it works, but that's our shortcut for how to use a number line. From here, we're just going to solve each of these problems. Subtract 3, subtract 3. Oop, that was a bad 3. Subtract 3, subtract 3. Now I got h is less than 2, and h is greater than a -8. So we have to look at what that looks like on a number line. So on a number line, we say, okay, -8 is more to the left, +2 is more to the right. We say h is, there are going to be open points at both of these, right? H is going to be less than 2, this direction of 2, and greater than -8, this direction for -8. So we want to say it's between those two values. So to say that you're between those two values, say h is in between these two values of -8 and 2. And I want set builder notation, so fine, we'll give it set builder notation. We'll put a line here, put an h here. We say it's the set containing h such that all of that is true about h. H is between -8 and 2. And it says, graph the solution set on a number line. We accidentally did that already. Let me make it nice and neat. We'll do a little straight line here. We'll say, okay, -8 is there, 2 is there, open point, line in between, done and done. Number 14, which is not a true statement. Okay, let's read. The empty set is the solution of this. Okay, gotta solve this one and see if it's true or not. Ready, set, absolute value of, let me label my work before I go too much further. So this is problem 14a. So this is going to be absolute value of k minus 2 and absolute value plus 1 is less than or equal to -2. From here, we need to isolate the absolute value first. So get rid of this 1 and then we'll drop it. So we're going to say -1, -1. And I get absolute value of k minus 2 and absolute value is less than or equal to -3. From here, I'm going to drop the absolute value symbol. And wait a second, I can't drop the absolute value symbol. Okay, everything in here can be negative, but after you take the absolute value, it has to be positive. Can you ever have a positive number here be less than a negative? No. So this one is no solution. And that's what it said. The empty set is the solution set. So empty set meaning that's another way of saying no solution. So that is a true statement. Oh, it is a true statement. We're looking for a not a true statement. So darn it, that is not correct because it's a true statement. So we have to cross it off. What about the next one? Let's talk about B. B is saying if you do the absolute value of k minus 2 and absolute value is greater than or equal to 2, it has those answers. Let's test. Okay, well, this one is true. You can be greater than a positive. So let's go ahead and separate this into two different inequalities. The first inequality is going to be k minus 2 is greater than or equal to 2, essentially just dropping the absolute value symbol. The other equation is going to be k minus 2, and then everything, that was k minus 3. K minus 2, everything on the outside gets multiplied by like a -1, so therefore it's going to be flipped, and it's a -2. And you're going to solve these all the same way, plus 2, plus 2, plus 2, plus 2. K is going to be greater than or equal to 4. K is going to be less than or equal to 0. And that's kind of what that's saying, right? K is greater than or equal to 4, K is greater than or equal to 4, or K is less than 0, or K is less than 0. That is true, and we're looking for something that's not true, so we can't choose that one. Okay, let's try C. By the way, when it's multiple choice, instead of select all that are true, if B is the answer, you don't have to go any further. Unfortunately, we haven't found the answer. Maybe it's C, maybe it's D. Hopefully it's C, so we don't have to do D. Let's try it. Absolute value of 3k plus 3 and absolute value is less than or equal to -9. And it says that's the solution. We shall see, shall we? All right, so this is going to turn into, drop the absolute value symbol. It's going to be 3k plus 3 is less than or equal to negative. Wait a second. Okay, absolute value of anything, even if it's a negative, is always, this thing is always going to be a positive because of the absolute value symbol. Is it possible to have a positive less than a negative? No, I almost fell into the trap, Mr. Sonnell. Good thing you caught yourself. The answer here is, again, no solution for the same reason that A is no solution. And it's saying it's that? No, you are wrong. That's false. Therefore, the answer is C. Whew, we're done. You know what I'm going to do. I'm going to go ahead and look at D just in case. Maybe I made a mistake, and I'm going to catch it right now. This is what you can do if you have enough time on the test, right? you're going to say if I have the absolute value of k minus 7 and absolute value is less than -6, it should have no solution. And that is true. Like, you could just stop right now, right? Everything right here has to be positive because it's inside of the absolute value symbol. Can you have a positive less than a negative? No, you can't. So that one, again, is no solution. Whew, that was nice that all three of them had no solution except for B. So that one is true. I want to write that in pen. It is true that one has no solution. Therefore, it's not the correct answer. This is the only false statement. That's one that we were looking for, the false statement. Oh my goodness, we're almost there. Oh, okay, 2 more problems here. Let's read. Number 15. The actual weight of a jar of peanuts tends to be within half an ounce or 0.5 of an ounce of its listed weight. Which graph shows the list of possible weights a jar of peanuts that has a listed weight of 6.5 ounces? Okay, you don't need to use math. Use logic. It has to be within. This is a word that means you have to be within a certain range. Like if I say you have to stay within the fence, you say, okay, like if I have a fence right here, you have to stay within that fence. You're not allowed to go outside. So it's everything inside of an area. So we're looking for everything that's inside of an area like this. This is incorrect. It can't be like everything on the outside, right? So it's not C just by the definition of what within means. And I need to be within half an ounce. So that means half an ounce this way and half an ounce this way. So just looking here, if like I'm finding the center, right? Here's the center. This is 1.5 this way and 1.5 this way, which does not make sense. Or what about this one? If I have the very center, that's half an ounce, that's half an ounce. This is the correct answer. And just looking at it again, this is the center. So this is within 1.5, within 1.5. That doesn't make sense. So let's cross off D as well. That one is just using logic. Sorry that I don't have very much work to show. You don't have to show work on the multiple choice if there isn't any work to be shown. Number 16. The equation for the boundary of the inequality is graphed, and it's y equals 3x minus 1. Is it? I don't know. Minus 1 is right there. It goes right 1 up 3. Okay, I believe you. Slope is 3. Y-intercept of -1. Write the inequality that represents the graph. Oh, the inequality. So it's this thing. You have to just choose that symbol, that symbol, that symbol, or that symbol, right? Okay, so the first thing that I notice is that this line is a solid line. Solid lines, again, this is an inequality that is solid. I can't spell solid correctly, apparently. And then this symbol means that it's dashed. If you have no equal to, it's a dash line. And this one doesn't have a dash line, therefore it's an equal to. So it's between one of two choices. Either y is less than or equal to 3x minus 1, or y is, I did two different y's, y is greater than or equal to 3x minus 1 because it's a solid line. So from here, which one is it and why? Well, I'm just going to randomly, there's a shortcut. I'll talk about the shortcut in a sec. I'm just going to randomly guess, oh, maybe it's this one. Oop, I double tap the Apple Pencil. I guess that switches it to the eraser. Maybe it's this one. So I'm going to plug in, maybe 0, 0 works. 0 is less than or equal to 3 times 0 minus 1. I'm doing this test point right here. This is a test point. What I'm hopefully going to find is this one doesn't work. Therefore, this is not in the solution. Therefore, you graph and shade the other side. Let's test. So 0 is less than or equal to, okay, 3 times 0 is nice and easy. It's 0. And 0 minus 1 is -1. Is 0 less than a negative? Unfortunately, no, it's not true. So this is false, which means this answer is not in the solution set, which is, look at that. This answer, this point right here is not in the solution set. It's shaded on the other side. So the correct answer is this one. We can just go ahead and say, that's the answer. Teacher, look, this is the answer right there. This one, if you plug in 0, 0, you'll find that it will be true. You'll say 0 is greater than or equal to -1. And that is a true statement, which means it needs to be in the solution set. But it's not shaded. That point is not in the solution set because it's not shaded where that point lives. Cool. Almost done. 2 more problems, almost done. Number 17, open source. Consider the graphs. Write the letter of the graph that represents the solution of each of the inequalities. Oh, we're just mixing and matching. Oh, wow. They all look like the same question. Okay. The first thing that I notice is that these two don't have an equal to sign underneath them, which means they have dashed lines. That means this one is either A or B. This one is either A or B. We just need to figure out which one is which. I told you I was going to do the shortcut. I'm really sorry. So here's a shortcut. If you get y by itself on the left-hand side, then this symbol right here will tell you if it's up or down. So I will write that down because I have a feeling that some people are watching the video right now and are going to get a little bit of extra help on their test. So I'll say if y isolated on the left, then this symbol means shade down, and this symbol, or the, like, you don't have to have the equal to, it can be just the greater than, means shade up. That's your cool little shortcut. And notice right here, this was saying less than, so less than means go down. So that's why it was shaded down. That's why, another reason that it's the correct answer. All right, number 17. I think we just have to, solve this question. Let's plug in a point 0, 0, because I'm noticing that this point right here in all of these graphs is not on the line. As long as you plug in a point that's not on the line, you're good to go. All right, so I'm going to go ahead and draw arrows so I can see what's going on. This one I'm going to try to do right here. So plugging in 0, it's going to be 2 times, here it is, 0 minus, okay, I'm plugging in 0, should be less than or equal to -3. All right, shall we? 0 times 2 is 0. 0 minus 0 is 0. Everything over here is 0. Let me show my work a little bit better. I have 0 minus 0, which is 0. All that is less than -3, less than or equal to -3. That is false. So if that's a false statement, that means that 0, 0 does not live in the shaded region of a solid line. So between our two solid lines, it is a false statement to say that this point is in the shaded region. This point is not in the shaded region. That is a false statement. So I'm going to say correct answer here is C. Why am I saying C? This one goes to C. And by default, that means that the other equal to sign must be a D. Okay, let's try to do this problem right here. So I'm going to say, this is going to be 2, there's my x minus my y is going to be greater than -3. I'm going to plug in 0, 0 yet again. And did you know that 0 times 2 is 0, and 0 minus 0 is 0? I don't know why I added the equal to. -3, greater than -3. Is 0 greater than a negative? Yes, yes it is. That's a true statement. If it's a true statement, it should be shaded wherever we have the point that we plugged in, 0, 0. So looking at this point versus this point, we want one that is in the shaded region. Is in the shaded region, B goes to this one right here. So we're going to say B. Therefore, by process of elimination, the last one is A. Last question of the practice test. Here we go. Graph that thing. Okay, well, typically speaking, we graph this in slope-intercept form. That meaning y is equal to mx plus b form. That means that y is by itself and isolated on the right-hand side. Y is right here. I need to get rid of u, and u. Let's do that. So let's move the -5 first, just randomly. -5, -5. Now I have 2/3 x minus y is less than 1. Let's go ahead and move the 2/3 x to the other side by subtracting a 2/3 x. Subtracting a 2/3 x. Now I double tapped the pencil apparently. I still have my -y is less than equal to all of that stuff. Oh, no. I got distracted. That's what we're doing to both sides. Therefore, this stuff is all canceled out. And I have a -y that's going to be less than 1 minus 2/3 x. It doesn't matter if you have the constant first or the variable term first. In this one, I have the variable term first. If it really is messing with you, I can go ahead and switch the sign as well out in front in here. Look, I can say, okay, -y is less than -2/3 x plus 1. You're allowed to just switch the order of these two terms. And then from there, I still don't have y by itself. There's this negative. So how do I get rid of the negative? My favorite way is multiplying both sides by a -1. Some people say you have to divide both sides by a -1. You're both correct. If I multiply both of these sides by a negative, watch what happens. Negative times negative is positive, and we have a positive y isolated on the left-hand side. And because we are multiplying by a negative, this sign switches from a less than to a greater than, and then this -1 is going to distribute into both of these terms. Let's do that now. -1 times a -2/3 is a positive 2/3 x, and a -1 times a positive 1 is a -1. We have our inequality ready to go, and we don't have any graph paper. I wish I had some graph paper. Do I have the, no I don't. Okay, I'm just going to go ahead and make my own graph on blank paper. So there is the y-axis, there is the x-axis. Do you know how you know? Because I've labeled them x and y. I'm going to go down 1, so there's -1, and that's going to be my y-intercept. So I'm going to put a point right there. And then from there, I'm going to go up 2, right 3, up 2, right 3, up 2, right 3, over and over and over again. If you forgot, slope, again, is always equal to the change in y over the change in x, or if you prefer, the rise over the run. So I'm going to go up 2, right 3. So here we go. I'm going to go up 1, 2, right, 1, 2, 3, and my new point that's on my graph is right here at the these coordinates are a little bit hard to see, but it's 3, 1 on this graph. And then I'm going to do it again. I'm going to go right 3, 1, 2, 3, and then up 1, 2. And then my new point is right here at, what is that going to be? 6, 4? Yeah. 6, 3, sorry. 6, 3 is on the graph. And then you can do the reverse as well. If I start at this point, instead of going right 3, I'm going to go left 3. And instead of going up 2, I'm going to go down 2. So I'm going to go, ready, set, I'm going to go left 1. Oh, I'm going to do this in black though. Left 1, 2, 3, down 1, 2. And you get to this point down over here. The coordinates of this point are -3, -3. And as long as you have a few points on your line, then you're ready to go. Okay. I didn't do it perfectly, but there is my line. It is incorrect. Let me talk about why. This symbol here means it is a dashed line. So if it's a dashed line, I just drew a solid line. Undo, try it again, Mr. Siddell. All right, so dashed line, and now I have a line that goes through these points, and do arrows on the end to say it goes forever and ever. And now I have to decide, am I shading the top or the bottom? I'm gonna use my shortcut that I just talked about on the last page over here. This shortcut, whoa. This shortcut says if y is isolated by itself on the left, which it is, if it's a less than, you shade down. If it's a greater than, we shade up. So over here, y is isolated on the left. It's a greater than, meaning shade up. So up here, I'm gonna go ahead and grab my highlighter tool, and I'm gonna find a cooler color. Yeah, do you know what's really cool? Gray, millennial gray. And then from here, I'm going to say gray, and let's go ahead and make it nice and large. Say, okay, all of that section up here is shaded. I shaded a little bit over the line, but I think you guys can forgive me. And there is our region. If you don't believe that it needs to be shaded up there, you can always plug in a test point. Let me show you that method as well, just in case you prefer that method. I'm going to say up here that y is greater than or equal to 2/3 x minus 1, plugging in a number for y is greater than or equal to 2/3, plugging in a number for x minus 1. The number that I decide to plug in is the origin, 0, 0. I always try to plug in numbers that have 0 because multiplying by 0 is so easy to do. When you multiply 2/3 by 0, it's just 0. And did you know 0 minus 1 is -1? Copy down the 0 and greater than sign. Is it true that 0 is... Oh, I meant to do this with a red laser pointer. Is it true that 0 is greater than -1? Yes, it is. This is a true statement. If it is a true statement, it is in the shaded region, and this shaded region represents all of the answers to our graph. Whew. Well, that was everything for our Integrated 1 Math Practice Test 6 for McGraw-Hill's Reveal Math Education. Thank you so much for watching. I'll see you guys later.